today we are going to discuss a very important concept in coordinate geometry, and that is section formula. Okay, and how we can apply this formula and which situation we are applying this formula in coordinate geometry. Okay, and let us see, children, how this is applicable. Okay, see, for that I am drawing a line segment, okay, AB. Okay, and I am dividing this AB, line segment AB, into 3 equal parts. Okay, that means here one point, this is the second point. So all together you can see 3 equal parts. Let it be C and D. That means AC equal to, and this distance CD equal to DB. Okay, that means out of these 3 equal parts, okay, if you are considering this AC is to CB. Okay, see children, this is AB and this length is CB. Okay, then what is the ratio? Here the sum of the ratio is 3. Okay, and out of this, 2 parts, 1 part is for AC. So 1 is to, and the remaining 2 parts, that is CD and DB, that is for CB, this whole length CB. Okay, that means here you can say that the ratio, okay, by which this point C dividing this AB in the ratio 1 is to 2. It is clear, children? Okay. See, suppose we need the ratio of AD, see children, AD and DB. This one, this length, DB. That means from this, okay, this AD is together with the 2 equal parts. So out of these 3 equal parts, AD goes to, that 2 goes to for AD. That means AD, if we need the ratio of AD is to DB, see children, DB, this is AD. Okay, that means you have to write this as 2 is to 1. Can you say that 1 is to 2 is equal to 2 is to 1? Of course not, children. That is x is to y is not equal to y is to x. X by y is not equal to y by x. So you have to consider separately. So we need the coordinate of that point C, which is dividing the line segment AB in the ratio 1 is to 2. Okay, here from the figure, this C dividing AB in the ratio 1 is to 2, right? And what we need? We need the coordinate or coordinates of that point, that is C. And for that you will be given the coordinates of A. Let it be x1, y1. Okay, x1, y1. Okay, and the coordinates of B is x2, y2. That is second point. Okay, x2, y2. See, you have to take, it would be better, let us assume that coordinates of C as x comma y. Here x1, y1, here x2, y2, and the required coordinates we are representing by C of x comma y. Okay, and you will be getting these coordinates of that point, that C, using the section formula. Okay, that means you will be given these n points, that is A of x1, y1 and B of x2, y2, and we need this coordinates of that point C, which is dividing this line segment in the ratio m, this is 1 is to 2. Okay, so in general, let us suppose this ratio is m is to n. Okay, that means the ratio by which this line segment AB get divided by the point C is m and is to n. Okay, that is here in place of m, that is 1 and n is 2. Hope the idea is clear, children. So in order to get that x coordinate, this is the formula, that is x is equal to mx2 plus nx1 divided by m plus n. See children, in this formula, in the LHS, I have written the x coordinate of C, the point that dividing this AB in the ratio m is to n. Okay, and that x is that x coordinate of C. And in order to get that x coordinate, this is the formula, mx to m is the ratio into the x coordinate of that the second point, x2 represent that, plus nx1 second ratio into x1, the x coordinate of A, the first point, divided by sum of the ratio m plus n. It is clear, children? And in order to get y is equal to my2 plus ny1 divided by m plus n. Okay, so this is the formula to get the coordinates of that point which is dividing the line segment AB in the ratio m:n. Okay, for example, in this case, in order to get the coordinate of C, in place of m you can substitute 1 and n as 2, and you will be getting this the coordinates of A and B, and for using this formula you will get the coordinate of C, that is x comma y. See here x and y represents the x coordinate of the point C, a required point, and y is the y coordinate of the required point, that is C. Hope the idea is clear, children. Okay, see, if suppose this point D divides this line segment AB, can we apply the same ratio? See, children, we can't. See, because from the figure, this point D, AD, that means AD is to DB. If that point D divides the line segment AB, the ratio also gets changed. That is AD, from A to D, that is 2 equal parts. Out of 3, that is AB get dividing into 3 equal parts, isn't it? So AD is 2 and the remaining portion is DB. Okay, so here the ratio is 2:1. Okay, so accordingly m and n will change. Okay, and so that you can easily find out the coordinates of D also. So for that, what you have to do? You have to represent these coordinates of D as x comma y. Okay, always that x represents the x coordinate of the required point and y represents the y coordinate of the required point. Okay, so that when you are taking the ratio, you should be very careful about that. Okay, see, suppose if you need, after getting this D point, this can be done in another way also. Okay, see, if see, after substituting this ratio as 2:1, okay, you will get definitely that coordinates of D, that is x comma y. See, in that case, suppose you need that coordinates of C. That idea is clear, children. We have that is the x value and what is it, coordinates of A and coordinates of B. And after applying the section formula, now you have the coordinates of D also. My point is this: will you get that coordinates of the C without using section formula? You can definitely use the section formula if in order to get the values of x and y for C by taking the ratio 1:2 you will be getting. But my question is, without using the section formula, okay, after getting the coordinates of D of x comma y using section formula by taking m:n as 2:1, okay, see, children, here the C is the midpoint of AD, right? Now you have the coordinates of D also using section formula. My question is, will you get the coordinates of C without using section formula? You can also definitely use section formula, you will get it. Okay, see, but since here C is the midpoint of AD, you can apply that midpoint formula. Okay, what is midpoint formula, children? That is very simple. That is, we already explained the midpoint by midpoint formula. Midpoint formula, the coordinates of x equal to x1 plus x2 by 2. Here x2 is, see, children, that should be taken. See, children, here x2 is the coordinates of D, the x coordinate of D. Okay, we have used that section formula in order to get to that the coordinates of D. Okay, and that x coordinate you have to write here x2, and y is equal to y1 plus y2 by 2. Here x is the x coordinate, represents x coordinate of the point C, and y represents the y coordinate of the required point C. Okay, so without using section formula, if you know the coordinates of D, okay, you can apply this midpoint formula, x1 plus x2 by 2 and y1 plus y2 by 2. In the same way, children, see, before you calculating D, suppose you have the coordinates of C, okay, by using section formula by taking ratio as m1:2. That means now you know this coordinates of C and B. We already given. So in order to get to the coordinates of D, since D lies exactly in between CEB, you can apply section formula. Okay, so these are the application of section formula. Okay, so by using these ideas, okay, we can easily complete all the problems of exercise 7.2. In the first question, find the coordinates of the point which divides the join of -1,7 and 4-3 in the ratio 2:3. That means here 2 points, the join of 2 points. So those 2 points, let it be A and B. This A and B, okay, get divided by a point. Okay, and let it be C. Okay, and this point C dividing the line segment AB in the ratio 2:3. In the ratio 2:3 means you can take M:(n) as 2:3. That means out of this 5 equal parts, this AB, suppose AB is divided into 5 equal parts. From where we got 5? The sum of the ratio. Okay, 5 equal parts. The 2 part is for AC and CB goes to, that 3 part goes to CB. That is the meaning. And we need that the coordinates of the C, that is, let it be X, Y. And this is X1, Y1 and this is X2, Y2. That order is very, very important. Okay. So the endpoints are X1, Y1 and that is the join of, that is A is, let A is -1,7 and B as 4-3. See, can we apply here this midpoint formula? We can't apply, children. In order to apply midpoint formula, the ratio must be 1. 1:1. M is, see, suppose here M is 2, N is 2:2. That means 2 equal parts, 2 equal parts. In that case only, or 1:1. Always midpoint formula, that ratio will be 1:1. Okay, but here the ratio is 2:3, so we can't apply. C is not the midpoint. If it is given C is the midpoint, you can apply midpoint formula. Okay, so here you have to apply anyhow that section formula. Okay, that means in order to get this x coordinate of the point C, what is the C for bisection formula? Bisection formula, x is equal to mx2 plus nx1 divided by m plus n. Okay, let C of x comma y is the required point. Okay, and in this required point, x you will be getting by applying this section formula. Understood? Here everything is given. M is given m as 2 and n is given as 3. Okay, and x2 is the x coordinate of the second point, that is given. X1 is given. Sum of the ratio is m plus n. Okay, in the same way you will be getting y also by applying the section formula, y in the section formula. Okay, so first we can find out the value of x coordinate, that is m is here 2 and x2 is 4 plus n is 3, x1 is x coordinate of the first point -1 divided by m plus n, that is 2 plus 3. Okay, so 2 4s are 8, -3, 3 into -1 divided by 2 plus 3 is 5 and 8 minus 3 is 5 by 5 and that is 1. So x coordinate is 1. And in order to get the y coordinate, that is my2 plus ny1 divided by m plus n. This is the formula. Okay, we can substitute m as 2 into y2, that is -3 plus n into y1. N is 3 into y1. This is x1 y1. Okay, and this is x2 y2. Okay, so divided by, so y1 is 7 divided by m plus n. We have seen that 5 here. Okay, 2 plus 3 is 5. So 2 3s are 6 minus 6 plus 21. 7 3s are 21 divided by 5. Okay, 21 minus 6 or 6 plus 21. Subtract, okay, and you will get here 15, the positive 15, 21 is a positive number, divided by 5 in the denominator and 5 in 15, 3 times. That means we have seen that y is equal to 3. So which is the required point? That is C of x comma y. C of x comma y is C of, in place of x you got it as 1 bisection formula, and 3. So this is the point, the coordinates of the point C which are dividing that join of A of 4 minus 1 7 and B of 4 minus 3 in the ratio 2:3. Now the third question, find the coordinates of the points of trisection of the line segment joining 4 minus 1 and minus 2 minus 3. Okay, the line segment joining 2 points. Okay, so let the 2 points are A and B. Okay, and the line segment joining these 2 points is this line segment AB, and the coordinates of A is given as 4 minus 1 and B as minus 2 minus 3. And what we need? We need the coordinates of the points of trisection. Okay, see children, trisection means this AB get divided into 3 equal parts. Bisect we know 2 equal parts. Okay, here trisection means 3 equal parts. That idea you should have, because otherwise we can't get it. Because here the ratio is not given. M:1 is not given. Instead of that, we have a clue in the question that points is dividing this line segment AB into 3 equal parts. Trisection is the meaning of the trisection is this. Okay, and here let C and here D. These are the 2 points. Okay, by which this AB is dividing into 3 equal parts. So actually what we need these coordinates of C as well as coordinates of D. That is what is asked. Find the coordinates of the points of the trisection. Okay, so how can we start? Let C of x comma y, C and D, the point C and D dividing, okay, divide AB into 3 equal parts. Okay, equal parts. But the ratio is not given, children, but that is very important clue. Okay, so bisection formula. Okay, see children, see here how can we find out the ratio? Okay, if you consider AC, we need AC, the ratio, that is AC and CB. Okay, after dividing that point C, okay, that AB by the point C, okay, that AB is divided by into 2 parts, not equal, 2 parts, that is AC and CB. In which ratio? That is AC is 1 out of these 3 equal parts, and for CB that is 2. Okay, so that is because of that point C, that line segment AB divided into 2 parts. One is AC and another one is CB in the ratio 1:2. Okay, so we need that coordinates of C. Let it be x comma y. First we are going to find out that x comma y, that coordinates of C. Okay, we have now the ratio. Okay, and we have an idea that is about the section formula is the required formula in order to get the answer for this question. Okay, so bisection formula. Okay, bisection formula, x is equal to, that is x coordinate of C. Okay, that is mx2 plus nx1 divided by m plus n. Okay, here m we have seen that 1 into x2. x2 is x coordinate of B minus 2 plus, what is n? n is 2. This is m is to n, that is 1:2. Okay, that is 2 into x1, 4 divided by m plus n, 1 plus 2. Okay, by solving 2 into minus 2, 1 into minus 2, plus 8, 2 4s are 8, and 3, this 1 plus 2 is 3. That is minus 2 plus 8 is 6 by 3, that is 2. That is x coordinate is 2. And in order to get this y coordinate, okay, the same, we can apply the same section formula and y coordinate, that equation, that is my2 plus ny1 divided by m plus n. M plus 1 we have seen that is 3. but there is a change in the numerator, that is m is 1 into y2. y2 is y coordinate of the second point, that is minus 3 plus n is 2 into y1 is minus 1 divided by 5. Sorry, 3. 1 plus 2 is 3. M plus n. Okay, so 1 into minus 3 and 2 into minus 1 minus 2 divided by 3. And minus 3 minus 2 minus 5 by 3. That means the coordinates of C, that is we have taken as x and y, is x we have seen that 2 and minus 5 by 3. This is the point, the coordinate of this first point, okay, and we need the second point, that is coordinate of D. Okay, see how this D can be found, children. Okay, and as I told in the section theory part, see when we look into this figure, you can see that this D is the midpoint of CB. Okay, if you want to apply that midpoint formula, you can apply midpoint formula. That would be a little bit easier than the section formula. Okay, so you can consider D as the midpoint of CB. That idea is clear? Or if you want to get to this coordinates of D by section formula, in that case AD, because of this point D, that AB get divided in the ratio, that is AD is to DB, the two parts, AD, this and this one, and DB, and in the ratio 2 is to 1. And taking M as 2 and N as 1, by using the same procedure, that same formula, you can get it. Or I would say midpoint concept would be a little bit easy for you, because it is very clear that D is the midpoint of CB, right? Now we have C, the coordinates of C, right? Okay, that is 2 and minus 5 by 3. Understood? So, since D is the midpoint of CB, okay, in order to get the coordinates of D of x comma y, so x is equal to, by midpoint formula, okay, okay, x is equal to x1 plus x2 by 2. Here what is x1? Here don't take this as x1, y1. Okay, here in CB, right, CB, this x1, y1 is the x coordinate of C and y coordinate of C. Okay, so don't take this 4 and minus 1 value, because we are considering CB and D is the midpoint. Okay, so x1 is, here we have 2, okay, 2 plus x2 here is minus 2, right? Okay, minus 2 divided by 2. Okay, that is 2 minus 2 is 0. 0 by 2 is 0 by 2. That is equal to 0. That is x coordinate of this point D is 0. And what we need? We need y coordinate. So y coordinate by section formula, y1 plus y2 by 2. Okay, we have considered that the D is the midpoint of CB. Okay, so y1, that is, which is the y coordinate, that is minus 5 by 3, plus y2 minus 3 divided by 2, this 2. Here the fraction comes, okay, so, and the multiplication, addition, so you have to cross multiply. So you will have minus 5 minus 9, 3 into minus 3 minus 9 divided by 3, and this under this division we have 2. So take the reciprocal and you will be getting as, this is equal to minus 5 minus 9 minus 14 by 3, and take the reciprocal of 2, that is 1 by 2. Okay, 2 and its reciprocal is 1 by 2, and multiply. And 2 in minus 14, 7 times. So minus 7 by 3. Minus 7 by 3 is the y coordinate of this point D. That is minus 7 by 3. So this is the final conclusion. That is C equal to the coordinate of C. We have seen that 2 minus 5 by 3 and required points and its coordinates D is 0 and minus 7 by 3. Okay. Now children, we are moving to the third question. It's a lengthy question. I have drawn figure for you and I will read the question. Okay. To conduct sports day activities in your rectangular shaped school ground ABCD, lines have been drawn with chalk powder at a distance of 1 meter each. 100 flower pots have been placed at a distance of 1 meter from each other along AD as shown in this figure. Niharika runs 1/4 of the distance AD on the second line and posts a green flag. Preet runs 1/4 of the distance AD on the 8th line and posts a red flag. What is the distance between both flags? If Rashmi has to post a blue flag exactly halfway between the line segment joining two flags, where should she post her flag? This is the question. That means we have a rectangular shaped school garden, that is here it is A, B, C and D. This is the school ground. Okay, and here 10 lines are drawn. Here the children are standing, okay, for posting different flags. And along AD, that is the length of the ground AD, okay, flower pots are placed. Okay, 100 flower pots are placed. For my convenience, I have marked up to 10. Okay, you consider this AB, the AD, the length is 100 meter. Okay, the width of 1 meter, the flower pot, here the first flower pot is placed, second flower pot, here the third one, fourth one, likewise. Okay, so what is asked? Here the one student, Niharika, post a flag, green flag. Okay, we should get the coordinate. Where exactly? Okay, she is from the second line and post a green flag 1/4 of AD. Okay, that coordinates are not directly given. This is the clue. 1/4 of AD, that is 1/4 of AD means 1/4 AD. The distance is given as 100. That is 4 in 125 meter. Okay, and it is given that AD equal to 100 meter. Okay, from this 100 meter length, she could post, okay, that green flag 25 meter on the y-axis. Okay, and here where she is standing, the second line. So from the second line, okay, you see that where is that 25 meter. Okay, so the coordinates of that green flag where the Niharika post, okay, that is 2 in the x-axis. Here let it be x-axis and this is the y-axis, right? Okay, so 25 meter along the y-axis. Okay, suppose and here 2. Okay, so from 2 and 25 in the y-axis. Okay, so the coordinates of green flag equal to x coordinate is 2 and y coordinate is this 25 along the AD. Okay, here the flower pots are placed. Okay, at a distance of 1 meter each. Okay, this is the way to get the coordinates of green flag. Okay, and then the secondly, the second student, Preet. Okay, she is in 8th line. So along x-axis, so x coordinate and she is placing red flag along this 8th position, 8th line she is standing. Okay, and she posts a red flag 1/5 of AD. Okay, so along this y-axis, okay, so 1/5 of 1/5 of 1/5 of 100, AD is 100. the total distance of the length of AD. So 1 by 5 into 100, that is 20. So y coordinate is 20 and where she is standing? On the 8th line. So x coordinate is 8. It is clear? So coordinates of red flag equal to x coordinate is where she is standing and where she kept the red flag, and that will give you, that the meeting point will give you the y coordinate, and that is 20. Okay, this is the way, children, to get the coordinates of green flag as well as the red flag. And what is the question? Another student, Reshmi, posed a blue flag exactly in the middle. Okay, that means suppose here is the green flag, okay, and here comes that red flag. So A and B. Okay, and in the midway of AB, suppose this is C. It is given in the question exactly in the midway of the line segment AB. Okay, so we have to get the coordinates of C using which formula? Midpoint formula, because C is the midpoint of AB that is given. Okay, and before that we have to find out that the the distance between this green flag, this is green flag, okay, green flag, and this is a red flag. Okay, distance between the green flag and red flag means using distance formula you can easily get the distance between green and red. And in order to get the coordinates of C, since it is given in the question, C is the midpoint of green and red flag. Okay, so we can use midpoint formula. That is clear? So first we are going to find out the length, the distance between red and green. Okay, by distance formula, okay, AB equal to square root of x1 minus x2 whole square plus y1 minus y2 whole square. That is x1 minus x2. x1 is 2 minus 8. Okay, 8 whole square plus y1 25 minus 20 whole square. Okay, so 2 minus 8 is minus 6 and its square is 36 plus 25 minus 20, that is 5. 5 square is 25. Okay, you will get 36 plus 25 is 61. That is root 61 units. Okay, meter, because AD is in meter, 100 meter. Okay, 1 meter apart. So this is the way to get the that is the distance between these 2 points, that is the green flag and the red flag, using distance formula. Okay, that is the first part. And in the second part, we should get the coordinates of this blue flag. That is, blue flag is lying exactly in the midway of that red and green. Okay, so by midpoint formula, okay, let it x and y are the coordinates of C. Okay, that is by midpoint formula. Okay, x is equal to x1 plus x2 by 2. Okay, that means x1 is here, that is green, that is 2 plus x2, that is 8 by 2, that is 10 by 2, and that is 5. Okay, and in order to get the y coordinate of blue flag, okay, that is y1 plus y2 by 2, and y1 is 25 plus 20 by 2. Okay, that is 25 plus 20 is 45 by 2, and on dividing 2.5, that is 22.5. So what are the coordinates of C? The point C of x comma y is equal to, that is 5 and 22.5. Okay, so this is